Workshop personnel has access to the CNC room. Take this door stop and make sure to wedge it underneath so that the door remains open. After 30 seconds, it will beep for 30 seconds. Turn on the light in the CNC room. The first thing you should do is to make a quick inventory and make sure that the tools that you intend to use are actually present in the workshop CNC room. So here we have number 5, tool index number 5, which we will be using as a clearance tool. Tool index number 10, which we will be using as a roughing tool. And tool index number 26. Which we'll be using as a finishing tool. If you cannot remember the product ID or the tool index of the tool that you intend to use, you can go to the Community Feeds and Speeds document where you have previously input these and see it's 5, 10 and 26. If you need visual help to identify the tool that has the product ID, the index number that you intend to use, you can simply click this photo and you see here in rows of 8 as their product ID or tool index what tool it is. So here we have tool number 5, tool number 10 and tool number 26. You can zoom in here. If you cannot find your intended tool here on the tool table, it might be residing in a already occupied tool holder, so check there as well. Having made a quick inventory to make sure that the tools that you intend to use are actually present so as not to make your preparations fruitless, we can move on to the machine. Make sure that the compressed air valve is open by turning it counterclockwise, so it resides in an upwards position. Make sure that the pressure valve at the back of the machine is at 100 psi. If it's not, like right now it is, but if it would not be, you pull this up and then to increase the pressure, you turn it clockwise. You will see that it goes beyond 100. Very slightly so, but it goes beyond there. And if you want to decrease, you turn it counterclockwise and it will decrease. So make sure that it's at 100 psi. When you're done, push it gently down. Very good. The coolant fluid used to cool the spindle is battery water, and you should make sure that the level of battery water here is between these two levels here. And right now it resides just above this one. It's good. The vacuum machine is behind this door. Open the door. Turn on the light to the right. And make sure that the oil gauge here is between 1/2 and 3.5. It should not be full and not below 1/2. Very good. If the machine has been turned off for at least 4 hours, then the first thing we should do after having booted up the machine is to warm up the spindle, the rotating motor, which drives the rotation of the tool. Thus, it is sound to, before even turning on the machine, make sure that we have in the tool holders, in any of the tool holders, a suitable tool for warming up the spindle. A suitable tool is with as small a diameter as possible, and it can be as short as possible as well. The main thing is that by warming up, we gently heat the temperature of the grease of the lubricating fluids of the spindle to operational temperature. And while doing such a warm-up, we do not want to strain the spindle with a large tool like this, which can weigh a significant amount. In the back here of the machine, we have 6 tool holders. Tool holder 1, tool holder 2, tool holder 3, tool holder 4, tool holder 5 and tool holder 6. Generally, the tools of previous operations are left in the tool holders. There is no mandatory policy of removing the tools having finished the toolpath, but it is your responsibility to make sure that the tool is adequately secured, that the router bit is adequately secured in the collet, so as to make the tool a safe tool to use. So if we choose one of these 4 tools, namely perhaps this one residing in tool holder 4, it seems to be the smallest of these 2. If we choose tool number 4 here as our warm-up tool, it is important that we remove the tool and make sure that it is sufficiently secured into the collet. So I will remove this tool with both hands and gently push it down, one hand above and one hand below. Here we have the tool, and you see the router bit is secured in a collet, which is secured by a nut, and it is attached to a chuck. We go over here, and here it is a purpose-made station for the tightening of the nut so as to secure the collet around the router bit. We'll use this tool here to secure it. I'll first put the whole tool inside the hole here, position it so as to make sure that the wrench is able to securely fit it there. Very good. Then we use this tool, attach it and rotate clockwise so as to make sure that it is securely fit. And by applying a significant amount of force here, I know that this, and while it did not move anything, I know that it is securely attached, that the router bit is securely attached in the collet, tightened by the nut, so that it is attached to the chuck correctly. Alright, I remove the wrench and we can put back the tool. Take note here that the chuck has this sort of inset and outset, and this is corresponding to this outset of the tool holder. So make sure to vertically co-align those, and it will be a smooth thing to, with both hands, attach the tool to the tool holder. Make sure that it's securely attached here in the tool holder. Tool holder 2 does not have quite a secure grip as the rest of them, but it is still reasonably secure as for the time being. If we know beforehand that we're going to use 3 tools, and we see here that there is only 2 sets of chuck and nuts available, the collets are of different variations depending on the shank size of the router bits, then it is a sound thing to, before starting the machine, to also remove, in this case, 1 tool, so that we have 3 sets of chucks and nuts. This is because when we start the machine we will be doing a warm-up, and doing a warm-up the spindle will warm up with tool number 4 in this case, as we designated previously, and it will do so by the far end of the machine bed, by the X positive end of it, and thus we cannot go to the proximity of that area during the warm-up. So let's do that beforehand now. We can take tool 1 here. Very good. And now when we have taken apart this tool, we have 3 available sets of shocks and nuts. Disassembling a tool is the same procedure as securely attaching the tool, simply backwards. So we position the tool here in this purpose-made hole, position the wrench there, and now very cautiously and with both hands rotate with this tool counterclockwise. With the grip loose, you can use your hand until it is at the next tight area, and then you can loose it again with the wrench. And then you continue with your hands. And when it is completely loose, you can remove first the router bits, retract the wrench and remove the shock, collet and nut. The tool should be put on the tool table in the relevant area with its diameter of the shank. So here we have 16mm shank and this is 60mm. If you are not sure, then measure with the caliper. The rest of the tool can be disassembled so that the nut is loose as well as the collet. Make sure that the collet is removed from the nut. It is done by very gently squeezing this part. The nut can be attached to the shock and placed here with the rest. The collet, if this was 16mm in diameter for the shank that resides in it, it should be in the 16mm column there. Now we have 3 sets of shock and nuts for our 3 tools that we intend to use. And all 3 tools are residing here on the tool table, since the tools that are currently in the tool holders will not be accessible during the warm-up. If the tool that you intend to use is currently residing in the tool in any of the tool holders, then it is still your responsibility to make sure that it is securely attached. So remove it temporarily from the tool holders and securely attach it in the purpose-built area. Now we are ready to start the machine. On the wall, switch the power switch from 0 to 1. And on the back of the machine, do the same for the power switch here, clockwise to 1. This will turn on the machine. On the CNC controller, we should await a confirmation that the machine has booted up. Now it says please wait, and it loads its software and plugins. Very good. Now we see here the main controller interface. The first thing we should do is to verify the integrity of the spindle's shock. And to do this, we can take this controller with us and go down here as far as the cable reaches, but not beyond. And here we have the spindle, and the most central part of it is the spindle's chuck, and we should make sure that the integrity of it is impeccable. It should be 100% secured by the spindle's grip claws. And we can verify this by going to the controller. And then you see here, the middle button here, the 5 button here. If we press shift so as to enable the shift, you see here that this shift icon here turned white. Then we can click 5 to enter the interface where manual shock control is enabled. And as you see here, the spindle is closed, but we can press the 8 button here to open it, so we should do so. Press 8 to open, confirm with enter. We want to open the shock. And as you heard, the shock descended here. Perhaps we should do that once again. I will close it with 2 and confirm it, and you see what is happening. It closes, and now it is retracted, and I'll open it again. 8 and enter to confirm. You see that it descended. And you also see it here, that spindle is open. Very good. What you should do now is very, very gently, no force involved at all, but very, very gently, just make sure that this does not move when trying to gently rotate it. You should not try with any force to rotate it. Just check that it is 100% secure here. Very good. Having done so, you can close the shock. Close the spindle so as to allow the shock to retract. So we press 2 here, 2 to close, and confirm with enter. Yes, and it retracted. Very good. Now we have done all things to make sure that the machine itself is in the condition that we expect. We have checked that the air compressor is at 100 psi. We have checked that the battery water coolant fluid, spindle coolant fluid, is of adequate levels, and we have checked that the oil levels for the vacuum machine is adequate as well as now the integrity of the spindle's chuck. Alright, we can press cancel to cancel out this interface. And now it is time to home the machine. We do this by clicking the shift button so as to enable shift, and then clicking this button on the far top left here. It will find the machine's hard home, so the position where all 3 axes are positioned right above here. Alright, with shift enabled, we click this button to home it. You see here that it's initializing spindle, the 5 horsepower Umbra. And now it's finding home, first in the Z axis, and that it's very easily found. It just moves the Z axis upwards until it reached its top position, and then it moves simultaneously both the X and Y axes until it finds, now it's going to find its Y0 first. 1. There it found its Y0, and when evaluating its X0, it will 3 times make such a movement. One, 2. It actually only did 2. Alright, and now you see here, when it has found its hard home, right about here, you now see on the CNC controller, you see run spindle warm-up using which tool number, and by default it is a tool number 1, but as you see there is no tool residing in tool number 1, and we, in previous steps, we designated tool number 4 as our intended warm-up tool. It has a small diameter and it's very short. It will not put additional strain on the spindle as it warms up. So here you click 4, and when you press enter, it will run the spindle warm-up. This is an operation which takes 15 minutes, so before confirming this you should be positively sure that you have done everything that you want to do in proximity of the far end of the machine bed. During warm-up you may still do things here at the tool table and here on the far end of the glass doors, of course, but you should not be in proximity of the actual warm-up. So it does take time to evaluate, have you done everything that you want to do? One thing that we should do is to move the computer outside of the CNC room, and that is one such thing that we can do now. So I'll do so, and here it is very important to make sure that you take great care not to damage the cables here. Right now it's only one cable here, but there will be 3 eventually, and you should take great care that none of these are damaged in any way. I'll gently move the computer table out here. And when you have positioned the computer table out here, when you adjust its position, make sure that these cables are not clipped or damaged in any way. So you can position them so that each of the 3 cables are positioned so that it's only one cable height. This is a little too much upward, so perhaps like this. Very good. And now we are ready to do the warm-up. So, as stated here, tool number 4 has already been entered here. And then when we press enter, it will start to warm up using a tool that we have previously designated and now that we have confirmed here as number 4. Before you press confirm, just be aware that during the warm-up you may be in the CNC room by the table here and here by the door, by the glass door, but you are not allowed to be in proximity of the far end of the machine bed. So before running the warm-up, if you need to clear any tool holder from its current tool so as to extract one additional set of nut and chuck, then you should do so beforehand. Alright, but having already done all those things and being ready for the warm-up, we can click enter to confirm this. This will make the CNC machine go to tool holder 4 and fetch tool number 4. It will move to a position above the tool holder ditch there, and it will begin to warm up. It will warm up in 3 stages. First at 6,000 RPM, then at 12,000 RPM, then at 18,000 RPM. Each set takes 5 minutes, so it takes roughly 15 minutes for the warm-up to be finished. And this is a good time to check your toolpath file with the computer, and also if you haven't already, to prepare your tool. During the warm-up, you can start this computer, if it's not already booted up. and log in with your KTH credentials. If you uploaded the toolpath files to your KTH user server account, then it can be easily accessed by going to your H drive, which is your personal KTH server account. And here we see the 4.nc files that we exported, that we post-processed and exported. You see here that it's 4, like we previously stated, because it's 1 with all toolpaths merged in one toolpath file, and the 3 individual toolpaths separately. Opening another Explorer window here with Control N, we can navigate to the system drive, the OS disk, the C drive here. And here we see that there is a directory called DNC files. This is the directory that is synchronized to the CNC machine by the Ethernet cable they are connected with. And here you simply make, you can right click here and make a folder of your own if you do not yet have one. And it's quite buggy or quirky with the KTH computers, or at least this one, because it deselects all the time. But if you have the opportunity, then just write here, Eric, no, did not, Eric, W perhaps, no, W, alright, and enter that one, and here is your CNC toolpaths directory, and all these subdirectories are synchronized to the CNC machine, but if you have your own, it just makes it easy to find your files. Alright, in the previous window we can either click and drag these, or perhaps we can copy them and paste them here. And now all 4 toolpath files are residing in a directory that is synchronized to the CNC machine. Very good. During an actual operation, when the tool engages in actual material, it is forbidden to be inside of this CNC room. You should be outside of these glass doors, so as to make sure that if the tool breaks, that no tool shattering comes your way, or if it comes your way, that the glass door takes the damage and not you. But during the warm-up operation, you are allowed to enter this side of the CNC room as long as you are not in the proximity of the warm-up tool over there. So you can, for these 15 minutes, you can perhaps prepare your tools. So let's do so. I will still do it after the warm-up has been completed, so as not to being forced to stream this. Take the 3 tools that you're going to use. So number 5 here, number 10, as well as number 26 in this case. Very good. Then take 3 sets of shocks and nuts. 1, 2, 3. Given these shank diameters, take the relevant set of collets. So we know that number 5 here is 16 millimeter in diameter for its shank. So we take a 16 millimeter collet, and we know that number 10 here is 10 millimeters in shank diameter. So we take a collet of 10 millimeters diameter. And we know that this is 8 millimeter in diameter, tool number 26 here. So we take one of these with 8 millimeter. Very good. And then the first thing we can do is to unscrew these nuts. Very good. And then Before attaching these parts, you should be really careful about making sure that there is no dust on the shank of any of the tools. The shank is the dull part of the length of the tool, where a portion of it resides in the collet. And as well make sure that there is no dust on the inside of any of these collets. Very good, and do the same for these nuts. This one was actually quite dusty, so this one we will take to the compressed air in the other part of the workshop. We'll demonstrate this later. And check the shocks as well. This was dusty. This had a little fragment of something inside, so we'll take that one as well. This one did not have any dust in. In these three we saw dusts, so we'll bring these three to the compressed air in the other part of the workshop. And with the compressed air pistol, we make sure that there is no dust in any of the parts that we are going to use. And then we begin to assemble the tools. The logic is this: you put the collet into a nut, and then you put the tool 2.5 centimeters into the collet that is residing inside the nut, and then with the nut and collet and router bit assembled, you gently screw it and fasten it on a chuck. So I will demonstrate this, but I will need both hands, and thus my mouth will be disabled. You see here on the nut that it is not symmetrical. It has a shape that allows for the collet to be easily entered and exited if you rotate it in a certain angle. This might be a little finicky, but just try and gently squeeze the collet so as to compress it, and that makes it easier for the tool to attach. Alright, that clicking sound is foreboding in a good way, and you can see that the two are at this stage they do not need to be perfectly attached. You see that there is movement here. It is only when we securely attach this nut and collet on the chuck that it will be rigid. And then, since we are going to insert the router bit 2.5 centimeters into the collet, we can make ourselves a favor as of measuring up exactly 25 millimeters like this. So 2.5 centimeters, and then we can just roughly make sure that we position our thumb here so that it's about 2.5 centimeters from the edge, and then I will use both hands here. We can insert this router bit this much into the collet. As you saw, I looked through the display of the cell phone, and thus I lost my sense of depth. But having inserted it 2.5 centimeters into the collet, we can now insert it or attach it to the chuck. And by fastening it with your hands, the tool itself or the router bit itself is still securely attached, so as to make sure that it does not dislocate itself in terms of the insertion amount. One can also verify this if you know the length of the tool. In this case, this tool number 5 is 93 millimeters long in total length, so we can simply measure it from the collets and upwards or downwards, depending on how you see it. And we saw here that it is 69 millimeters of exterior length, so 93 minus 69 is 24 millimeters, and 24 millimeters is an adequate insertion amount. It should be about 2.5 centimeters. The main point is that it is not inserted more than 3 centimeters, because that could mean that it is less secure in terms of avoiding such a terrible accident as in the autumn of 2020, where the tool, having engaged in the material but not being properly fastened by the collets and not properly inserted into the collets, that it dislocated itself upwards and crashed into the spindle and destroying the spindle. We want to avoid that by inserting the tool, the router bit, into the collets of 2.5 centimeters approximately. With the router bit fastened with your hands, it is secure enough so as to make sure not to dislocate it vertically, but we should make sure to fasten it in the purpose-built station there. So we position the tool inside the hole here. We rotate it so that the wrench can properly fasten it there. And then we fasten it with this tool. And please use 2 hands and fasten as tight as you can. Very good. You can put back the tool. You can retract the wrench. And here you have a safely assembled tool. And this should be placed in the tool holder that the toolpath is going to fetch it at. And we know that since this is our clearance tool, we're going to use it, so we have already designated for it to be used with our clearance toolpath. Our clearance toolpath uses the tool residing in tool holder 1. In the toolpath file it says tool 1 should be used, and since this is the tool that we're actually going to use, we should make sure that it is residing in the correct tool holder 1. This is very important because the machine itself is not aware of what tool is actually residing in the tool holder. After calibrating, it knows its length and uses that calibrated length to assess the position of the tool in the Z-axis in regards to the work origin and the toolpath coordinates. But it is very important that you, as a human, have 100% understanding of where which tools should be put. Now this tool is used for our first toolpath. For our toolpath with a designated tool number of 1, it should be positioned in tool holder 1. Alright, and this is our first assembled and properly placed tool. Tool number 1 residing in tool holder 1. And now we can simply repeat the same procedure for the other tools. But before doing that, we can make sure that tool holder 2 as well as 3, which are the other 2 tool holders that are going to be used in this series of toolpaths, are not occupied. So we can move these two tools currently residing in tool holder 2 and 3 to tool holder 5 and 6. Now tool holder 2 and 3 are unoccupied. Alright, so we repeat the procedure for the other two tools. Very good. Now we have all three tools that are being used for the three tool paths that we have prepared in their correct tool holders. 1 for the clearance tool path, 2 for the roughing tool path, and 3 for the finishing tool path.